Hello, Algebra Scholars. Section 3.3 is on graphing and intercepts. We'll start with the second idea first. As you can see here, I wrote down the definitions. An x-intercept is the point or points where a graph crosses the x-axis. X-axis being this guy here. And the y-intercept is the point where a graph crosses the y-axis. Notice the use of the singular here and the plural here. For us, at this point in your mathematical lives, a graph can have more than one x-intercept, but it can only have at most one y-intercept. So let me grab my red pen here, and I'm going to draw a graph on this graph paper. Just going to sketch one out there without really trying to do too much. And I'm going to put a dot where it crosses the x-axis, and I'm going to put a dot where it crosses the y-axis. So the place where it crosses the x-axis is right here, and it looks like its coordinates are approximately -3, 0. That would be the x-intercept. Over here is the y-intercept. Looks like it crosses at 0, 2. And we would write that as the y-intercept. So here's another graph for us to take a look at. Notice that it appears to have 2 x-intercepts and 1 y-intercept. So the x-intercepts, do the one on the left first, 1, 2, 3, 4, 5, 6. It looks like it's at about -6, 0, and the one on the right appears to be at about 2, 0. And then the y-intercept is at 1, 2, 3, 4, is at about 0, -4.5. But here's a couple of important things here. One, you should note that you can have more than one x-intercept. That's fine. The second important thing here that you should note is that for every x-intercept, the y-coordinate is always 0. And for every y-intercept, the x-coordinate is always 0. And that is worth writing down. So let's say it this way. For every x-intercept, the y-coordinate is always 0. And then we can say for every y-intercept, the x-coordinate is always 0. Very important. So that last idea is important because if I ask you to find the x and y intercepts of this equation, it's very easy to do. We'll make a very small table of values, and to find the y-intercept, we will let x be 0. So we'll substitute 0 in for x right here, and we end up with the equation 5y equals 15. Because the x term is gone, so y must equal, that's right, 3. And then to find the x-intercept, we will plug in 0 for y. And when we do that, we end up with the equation 3x equals 15, so x must equal 5. And what we end up with are 2 ordered pairs. And the ordered pairs are 0, 3, which we will plot as our y-intercept. Notice how it's on the y-axis. And we'll plot the point 5, 0, which is our x-intercept. Notice how it is on the x-axis. So unlike the last section where we're making a table of values and plotting 3 random points, we're still sort of making a table of values, but we're only plotting 2 points and we're plotting two very specific points. The points where our line crosses the y-axis and the point where our line crosses the x-axis. Let's try one more of those. 2x minus y equals 8. Put in a 0 for x, and we'll put in a 0 for y. Those will be our 2 points. Remember, when you're putting in a 0 for x, you're really finding the y-intercept, and when you put in a 0 for y, you're really finding the x-intercept. So be careful with that. So when we plug in 0 for x right here, we end up with y equals negative 8. And then when we plug in 0 for y right here, we end up with x equals 4. So the point 0, negative 8 is here, our y-intercept, and the point 4, 0 is here, our x-intercept. I missed those points entirely with my line, but you know what I mean. And then the final idea in this section is about horizontal lines and vertical lines. And it's a pretty easy idea. If you have an equation that has just y in it, like this one, y equals a number, or just x in it, like this one, x equals a number, you'll either end up with a vertical or a horizontal line. For example, if we just have y equals 4, or if we just have x equals negative 3. Notice in this first equation, y equals 4, there's no x, it's just y is 4. So no matter what x does, how far we go left and how far we go right, the y coordinate is always going to be 4. So if x is 1, y is 4. If x is 6, y is still 4. If x is negative 10, y is still 4. So no matter what x does, y is going to be 4, and that gives us a horizontal line. And then in the second example, x is going to be negative 3. So x is going to be negative 3 over, but y can be anything. So if x is negative 3, y might be 0. If x is negative 3, y might be 4. If x is negative 3, y might be 9, and so on. And you see that we end up with just a vertical line. And that's pretty much it for this section. Actually, I lied. There's one tiny little final idea left here where I give you the line and you tell me what the equation is. It's the exact opposite of what we just did. So I have 4 lines here, lines numbered 1, 2, 3, and 4, and you're supposed to tell me the equation. Lines 1 and 2 are clearly vertical lines. Okay, the 2 black lines are both vertical lines. So we know that any vertical line always comes in the form of x equals some sort of number. What number is it? 1, 2, 3, 4, 5, negative 6. So x equals negative 6 is the equation of line number 1. X equals 1, 2, 3, 4, 5, 6, 7, 8 is the equation of line number 2. The last 2 lines are both horizontal lines, and they come in the form of y equals a number. So line number 3 is clearly 2 up, so it's y equals 2. And line number 4 is 8 down, so it is y equals negative 8. Thanks for listening.